An entire continent lies hidden beneath the North Sea, a lost world called Doggerland. This is just one of the sunken landscapes that vanished when the oceans rose at the end of the last ice age, swallowing the very ground where ancient humans lived, hunted, and built their societies. By the end of this journey, you will see the map of human history redrawn, revealing chapters erased by the sea. We will uncover how archaeologists are now finding these drowned civilizations and what their discoveries tell us about our own future on a warming planet. How much of our past is still waiting on the ocean floor? The world we know was forged by an epic meltdown. Around 20,000 years ago, the planet's great cold snap began to relent. This was the start of the Great Thaw, a planetary transformation that would completely reshape the human story. Across northern continents, ice sheets of unimaginable scale, some towering miles high, began to disintegrate. This slow-motion collapse, a process scientists call deglaciation, unleashed a torrent of fresh water into the Atlantic Ocean. Imagine the entire landscape groaning and shifting under the weight of all that vanishing ice. This was not a single event but a relentless, creeping process that unfolded over more than 10,000 years. The result was a staggering rise in global sea levels. The oceans climbed by approximately 120 meters. That is the height of a 40-story building. This was not a flood in the way we think of a biblical deluge. It was a slow, unstoppable drowning of the land. Vast plains that once stretched between continents, fertile valleys teeming with life, and entire forests were gradually swallowed by the advancing sea. The coastlines we see on modern maps are merely the most recent version of our world, a snapshot in a much longer, more dynamic story. To find the lost landscapes where our ancestors truly lived, we must first understand this global transformation. The key to unlocking these sunken civilizations lies beneath the waves, on the continental shelves that were once dry, habitable land. This ancient shoreline, the Paleo Coastline, was the stage for a lost chapter of humanity. The term itself describes the edge of the world as it was during the deepest cold of the Ice Age. But this was never a fixed line drawn on a map. It was a moving frontier, creeping inland for millennia as the meltwater poured in. To stand on that Paleo coastline 20,000 years ago would be to look out across lands that are now fathoms deep. With so much of the planet's water frozen into colossal ice sheets, the global sea level was over 100 meters lower than it is today. This drop exposed the continental shelves, the gently sloping plains that fringe the continents. What we now know as the stormy North Sea was once a vast, low-lying plain called Doggerland, connecting Britain to Europe. The Persian Gulf was a fertile river valley, a green oasis, and perhaps most famous of all, the Bering Land Bridge was a wide, grassy corridor linking Asia to the Americas. These were not minor land bridges but entire ecosystems, rich with game and resources, ripe for human exploration. Piecing together the map of this lost world is a monumental scientific puzzle. Researchers use complex models that weave together climate data and geology. They extract long tubes of sediment from the seabed, reading the layers like a history book to find traces of ancient soil, pollen, and even freshwater peat. They analyze the fossils of microscopic sea creatures to reconstruct past ocean temperatures. All of this evidence is plotted against what is known as the sea level curve, a graph that tracks the ocean's dramatic rise. Pinpointing the location of these vanished shores is the essential first step, the foundation upon which all other discovery rests. It turns the empty blue on a modern map into a detailed landscape of hills, rivers, and valleys. And with that map slowly coming into focus, a compelling question emerges. If these were thriving landscapes, then who walked there? The logical conclusion was almost inescapable. If the oldest coastal settlements we find are perched on high ground today, then the most desirable real estate of the ancient world must lie beneath the waves. For much of history, this was little more than an intriguing speculation. Then, in the 20th century, a handful of researchers began to give this idea a scientific foundation. They argued that the river valleys and fertile plains we know are merely the leftovers, the high ground that survived the deluge, the true cradles of early human society, the areas with the richest soils, the most reliable fresh water, and the greatest abundance of game were almost certainly the vast lowlands that were gradually inundated. This was the first major hypothesis, the pioneering idea that our maps of prehistory were tragically incomplete. Figures like Graham Hancock popularized the dramatic potential of these lost worlds, while academic institutions, such as the University of Edinburgh with its dedicated Doggerland research, began the painstaking work of proving it. This was a fundamental challenge to a long-held belief, the traditional narrative that civilization was born exclusively in the river valleys visible on modern maps like the Tigris and Euphrates. Why would the very first farmers and town builders ignore the enormous, fertile plains that once stretched before them? This theoretical shift did more than just add a new chapter to history. It created an entirely new search grid, transforming empty ocean into a landscape of mystery. It forced us to ask if these sunken worlds existed, which legendary lost lands might be more than just myth. The shadow of Atlantis looms large over any map of sunken worlds. Plato's ancient story of a sophisticated island nation swallowed by the sea in a single day and night has captivated imaginations for millennia. It is easy to dismiss the tale as pure philosophical allegory, a cautionary myth about hubris. Yet, could there be a sliver of geological truth buried within the legend? Some researchers propose that the dramatic destruction of Atlantis echoes a real and catastrophic event from the ancient world, the colossal volcanic eruption of Thera around the year 1600 BC. This cataclysm utterly devastated the Minoan civilization on Crete, a sophisticated Bronze Age culture that would have seemed advanced and mysterious to later Greeks. The ash fall, the tsunamis, the sheer scale of the disaster could have easily been remembered and distorted over centuries, transforming into the story of a continent sinking beneath the waves. But there is another, slower possibility. Could the legend also preserve a collective memory of the great drowning itself, the relentless rise of the oceans that consumed the coastal plains where early societies thrived? For the Neolithic farmers living along those shrinking shores, watching their ancestral lands vanish inch by inch over generations, it must have felt like the world itself was being erased. The story of a lost paradise beneath the sea would be a powerful way to explain that profound loss. Scholars meticulously pick apart Plato's geographical clues, comparing his descriptions of rings of land and water to actual submerged landscapes. The search for a historical Atlantis is a perfect example of the delicate dance between myth and science, where researchers must separate poetic embellishment from potential kernels of truth. This legendary quest, while often speculative, fuels a more tangible and evidence-based search for the very real civilizations that the rising seas did claim. The cold waters of the North Sea conceal what was once a vibrant heartland. Doggerland, often called Europe's lost Atlantis, was no myth. For thousands of years, this vast plain connecting Britain to the Netherlands and Denmark was a rich, habitable world. It was a landscape of rolling hills, winding rivers, dense forests, and marshlands, teeming with red deer, wild boar, and even mammoths. Mesolithic hunter-gatherers tracked these herds across this fertile land, leaving behind the evidence of their lives in the form of finely worked flint tools now dredged up from the seabed by fishing trawlers. Modern science has resurrected this lost world not with shovels but with sound. Researchers use seismic survey data, essentially bouncing sound waves off the seabed, to create a detailed topographic map of the drowned landscape. They can trace the courses of ancient rivers like the Schotten River and identify the outlines of vast buried lakes. Core samples pulled from the seafloor add another layer to the story, revealing layers of peat, pollen, and soil that confirm this was once a living, breathing ecosystem. The end of Doggerland was a slow, relentless process, but its final separation from the continent may have been shockingly sudden. Around 6,500 BC, a massive underwater landslide off the coast of Norway, known as the Storegga Slide, is believed to have triggered a colossal tsunami. A wall of water would have surged across the remaining low-lying plains, devastating the coastal communities and finally severing Britain from mainland Europe. This single event transformed an island into an island, forever altering the course of human history in the region. Doggerland stands as a proven case, a concrete model of a sunken civilization. It shows us exactly how to look for others, moving from the cold northern waters to the warm, tropical seas of Southeast Asia, where another vast continent may have vanished beneath the waves. Far to the southeast, another continent sank beneath the waves, while Doggerland connected Europe. A far larger landmass once unified the tropical world of Southeast Asia. This was Sundaland, a sprawling subcontinent that connected modern-day Indonesia, Java, and Borneo directly to mainland Asia. At the peak of the Ice Age, this was not an archipelago but a single, continuous landmass nearly the size of India. Its flat, fertile plains were a paradise of rainforests and savannas, a crucible of biodiversity, and a superhighway for the earliest human migrations out of Africa. People and animals moved freely across this vast territory, leaving a trail of archaeological evidence that now lies scattered across the seafloor. Then the waters came. The rising oceans did not just flood the edges of Sundaland, they utterly dismantled it. The sea crept up the river valleys, slowly drowning the lowlands and isolating the highest hills, which became the thousands of islands we see on the map today. This was a catastrophic loss of territory, a fragmentation of a world that forced human societies into a corner. With their vast hunting grounds disappearing, communities were pushed toward the remaining coasts. This immense environmental pressure may have been the very catalyst that spurred one of humanity's greatest innovations, the development of purposeful seafaring. Could the first ocean-worthy boats have been born from this necessity, an urgent response to a drowning world? The memory of this great loss seems to echo in the region's oral traditions. Widespread flood myths tell of ancestral lands swallowed by the sea, stories that could preserve a collective trauma spanning hundreds of generations. Sundaland stands as a monumental example, proving that the drowning of coastal plains was not a regional event but a global catastrophe that reshaped human destiny across the planet. And this pattern of loss was repeated again in the frozen reaches of the far north. But the story of lost landscapes is not confined to the tropics. To the far north, another land bridge once defined the human journey. Beringia was a vast, dry plain, a continent-sized gateway that linked Siberia to Alaska for thousands of years. This was no narrow, precarious path. At its greatest extent, it stretched over 1,000 kilometers from north to south, a wide and grassy steppe teeming with life. Herds of woolly mammoth, steppe bison, and caribou roamed this fertile ground, and the first human explorers from Asia followed these animals into a completely new world. The existence of Beringia was made possible by the same global phenomenon that exposed Doggerland and Sundaland. With so much of the planet's water locked up in ice, the sea level dropped, revealing the shallow continental shelf of the Bering Strait. This was not a bridge in the sense of a human-made structure, but a natural, habitable landscape that emerged from the sea. The people who crossed it were not just briefly passing through. Recent archaeological and genetic evidence suggests that some groups may have lived in this region for millennia, isolated from both continents, in a sort of genetic refuge before finally moving south into the Americas. Then the climate began to shift. The great thaw that flooded Europe and Asia also sealed the fate of Beringia. As the glaciers melted, the oceans rose, and salt water began to pour back into the low-lying plain. This was a slow, inexorable process. The grasslands gradually shrank, the coastlines crept inward, and the animal herds were forced to adapt or move. Finally, around 11,000 years ago, the rising Pacific and Arctic oceans met, and the land bridge was completely severed. The gateway to the Americas slammed shut. This single geological event had profound and permanent consequences. It physically isolated the populations of the Americas from their Asian ancestors for thousands of years, allowing cultures to develop along entirely unique trajectories. The story of Beringia powerfully demonstrates that sea level change is not just about lost land, but about lost connections. It rewrote the map of human migration and shaped the destiny of two hemispheres. To find the physical proof of these sunken worlds, we cannot rely on myths or maps alone. We need to send our senses into the deep. Finding these lost landscapes requires a kind of digital vision, a way to see through the deep, dark water. The first step is to create a map, and for that, researchers rely on sound. Side-scan sonar and multi-beam bathymetry are the workhorses of this underwater exploration. Think of them as powerful acoustic flashlights. A vessel tows a device called a towfish through the water, which emits fan-shaped pulses of sound waves down toward the seabed. The strength of the returning echo paints a detailed picture of the texture and composition of the seafloor. A hard, rocky surface will reflect a strong signal, while soft mud will absorb much of the sound. This process creates stunningly high-resolution images, revealing features as small as a single boulder or, more importantly, the unmistakable, meandering path of an ancient river channel cutting across the continental shelf. It can even show subtle, mound-like anomalies that could be the remains of artificial structures, the ghostly footprints of human settlements. But what about the evidence buried beneath several meters of sand and silt? For that, archaeologists use a tool called a sub-bottom profiler. This device sends lower-frequency sound waves that have the power to penetrate the seabed. The waves bounce back from the different layers of sediment, creating a vertical slice, a cross-section of the ground beneath the waves. It works on the same principle as an ultrasound, allowing scientists to read the stratigraphy, the buried history book of the ocean floor. They can identify layers of ancient soil, deposits from old riverbeds, and even pockets of freshwater peat, all of which confirm that this was once dry land. To narrow the search for human activity, another instrument comes into play, the magnetometer. This device measures tiny variations in the Earth's magnetic field. When ancient humans lit fires, the intense heat would permanently alter the magnetic minerals in the surrounding clay and stone, creating a local magnetic anomaly. The same principle applies to piles of discarded pottery or any other materials that have been fired. A magnetometer towed behind a survey boat can detect these subtle magnetic fingerprints, pinpointing the locations of ancient hearths, kilns, or workshops that are completely invisible to the naked eye. This entire suite of non-invasive tools allows researchers to survey vast areas of the seabed, quickly identifying the most promising targets for the next most challenging phase, the physical recovery of artifacts from the deep. Mapping a lost riverbed from the surface is one thing, but touching the past requires a descent into the deep. Underwater excavation is where theory meets the muddy, difficult reality. Once a promising site is identified by sonar and magnetometers, archaeologists face a monumental task. Every dive is a battle against the elements, a slow, meticulous, and incredibly expensive operation. Teams of divers must work in near-total darkness, fighting unpredictable currents and limited air supply. Their only guides the beams of their headlamps cutting through the silt. They cannot simply dig. Every movement risks disturbing the site or destroying a fragile artifact. Instead, they use small hand-held dredges that act like underwater vacuum cleaners, carefully sucking away layers of sediment to expose the ancient ground surface below. Every single object, from a tiny flint flake to a massive stone monument, must be photographed, measured, and its exact position recorded before it can ever be moved. This painstaking process is the only way to preserve the context, the story of how these objects were left and what they meant to the people who used them. Yet, this challenging environment holds a remarkable secret. The very water that hides these sites also protects them in a way dry land cannot. On land, organic materials like wood, leather, and textiles rot away in centuries. But buried in the oxygen-poor mud of the seafloor, these same materials can survive for millennia. A wooden tool, a woven basket, or even food remains can be preserved in stunning detail, offering an intimate glimpse into daily life that is almost never available from terrestrial sites. The trade-off is their fragility. The moment these waterlogged treasures are brought to the surface, the clock starts ticking. Exposure to air can cause them to shrink, warp, and crumble to dust in a matter of hours. This is where a second, equally critical phase begins, a race against decay in the conservation lab. Recovered artifacts are immediately placed in freshwater tanks in specialized laboratories. The goal is a slow, controlled process of desalination, gently drawing out the millennia of salt water that has saturated the object's cells. For a large piece of wood, this stabilization process can take years. The proof of this method's incredible potential lies in places like Atlat Yam, a Neolithic village submerged off the coast of Israel. There, on the seafloor, archaeologists found not just tools, but an entire community, complete with stone houses, a ritual circle of massive standing stones, and the haunting remains of human burials, their skeletons still lying in their graves. These are not just artifacts, they are frozen moments, tangible proof of lives lived on a shoreline that vanished beneath the waves. Each carefully recovered object is a voice from a drowned world, speaking across thousands of years. The cold, dark waters of the Baltic Sea guard secrets in their mud. Here, in the shallow basins off Denmark and Sweden, the low salinity and oxygen-poor sediments have created a perfect time capsule. Divers have uncovered entire Mesolithic landscapes, where the wooden bones of ancient life are preserved with almost impossible clarity. They have found elaborate fishing weirs, complex fences built to trap fish as the tide receded, still standing where they were placed thousands of years ago. They have lifted entire log canoes from the seabed, their hulls shaped by stone tools, ready to glide across waters that no longer exist. These are not just scattered artifacts, but the intact infrastructure of a coastal society, frozen at the moment the sea took it. This incredible preservation paints a vivid picture of a people intimately connected to their watery world, a picture far richer than anything we could reconstruct from stone tools alone. The story in the Black Sea is different, written on a far more catastrophic scale. Here, a bold hypothesis suggests that around 7,600 years ago, the rising Mediterranean Sea finally broke through the Bosporus Strait. What followed was not a slow creep but a titanic, roaring deluge, a wall of salt water 200 times more powerful than Niagara Falls, is believed to have crashed into a vast freshwater lake that lay hundreds of feet below. The shoreline would have retreated by a mile a day, drowning the fertile valleys where early farmers had settled. This event, if it occurred as described, would have been an apocalypse for those communities, a world-ending flood seared into human memory. While the search for definitive proof of these submerged villages continues, expeditions led by figures like Robert Ballard have found ancient shorelines, riverbeds, and even a single, tantalizing wooden structure far beneath the surface. The evidence from these inland seas is building an undeniable new narrative. It proves that the rising waters did not just reshape empty landscapes, they erased the very homes of our ancestors, from the intricate fishing grounds of the Baltic to the potential farmsteads of the Black Sea. This pattern of loss connects the cold northern waters to the sun-drenched Mediterranean, where another submerged site offers a snapshot of a village caught in time. The oldest known submerged city in the world lies just a few meters beneath the clear waters of a Greek bay. Pavlopetri is a stunning time capsule, a fully planned Bronze Age town that sank beneath the Mediterranean over 5,000 years ago. Its foundations are not scattered stones but the complete layout of a community. You can swim along its ancient streets, past the outlines of its buildings, and see the chamber tombs where its people were laid to rest. This is not a landscape lost to the slow creep of sea level rise, but a city that met a different, more sudden fate. The same tectonic forces that built the Greek peninsula also caused its coastal lands to fracture and sink, likely during an earthquake, plunging this urban center into the sea. It offers a hauntingly clear window into a sophisticated society that vanished in a geological instant. Further west, in the Bay of Naples, the sunken city of Baiae tells a later but equally dramatic story. Here, the Roman elite built extravagant villas and bath complexes to enjoy the volcanic hot springs. But the same volcanic activity that provided the luxury also caused the land to sink, a process called Bradisism. Over centuries, the marble floors and elegant statues of this Roman pleasure resort slowly descended into the shallow sea, where they now form an underwater museum of opulence reclaimed by marine life. These Mediterranean sites are fundamentally different from the drowned hunting grounds of Doggerland or the submerged plains of Sundaland. Pavlopetri and Baiae were not swallowed by a global deluge of meltwater. They were lost to local geological violence, to earthquakes and volcanic subsidence that dragged entire urban centers into the sea. This reveals a crucial distinction in our search for sunken civilizations. Some were lost to a global environmental change, while others fell to the unpredictable fury of the Earth itself. Their ruins pose a powerful question. If such significant places could vanish so completely, how long would their memory last on the lips of the survivors? The story of a great deluge is etched into our oldest myths. From the epic of Gilgamesh in ancient Mesopotamia to the biblical account of Noah's Ark, and from the flood legends of the Aboriginal peoples of Australia to those of indigenous tribes in the Americas, these narratives form a chorus of human memory. They all tell of a world-destroying flood, a divine punishment or a natural catastrophe from which only a handful of people survived. The sheer universality of these stories is staggering. It begs a profound question. Could these be more than just religious allegories? Could they be the faint, distorted echoes of a real, global event, a trauma so deep it was seared into the collective psyche of humanity? Generations of our ancestors did not simply watch the ocean rise. They experienced its relentless advance as a theft of their world. The fertile plains where they hunted, the rivers where they fished, the sacred groves where they buried their dead, all of it was slowly consumed by the salt water. This was not a single storm or a bad season. It was an unstoppable force that unfolded over centuries. For a community tied to the land, watching their home vanish inch by inch must have felt like the end of everything they knew. The story of a great flood sent by the gods would be a powerful way to explain this incomprehensible loss, to make sense of a world that was literally disappearing before their eyes. The details in these myths often align with the scientific evidence in startling ways. Many stories describe not just rain, but the oceans themselves rising up. They speak of survivors fleeing to high ground, of a world remade, and of a coastline that was forever changed. This is not the stuff of a local river flood. It is the precise, terrifying experience of post-glacial sea level rise. The geological record confirms a catastrophic reality, and the cultural record seems to remember it. While we can never prove a direct, one-to-one link between a specific myth and a specific submerged valley, the pattern is too compelling to ignore. These flood myths are the human heart of the scientific data. They give voice to the fear, the loss, and the resilience of those who lived through the Great Drowning. They remind us that climate change is not a new phenomenon, but an ancient force that has always shaped human destiny. And if our ancestors preserved the memory of rising waters for thousands of years, what does that tell us about our own future on a warming planet? This cultural evidence forces us to look beyond the sonar maps and core samples, to consider the lasting psychological impact of a lost world. These ancient flood myths find a powerful echo in the cold, hard logic of modern supercomputers. Scientists are now building digital time machines, constructing intricate models of our planet's ancient climate to understand exactly how those waters rose. These are not simple animations, they are complex simulations that weave together countless threads of data. The models ingest information from deep ice cores in Greenland and Antarctica, which hold tiny bubbles of the ancient atmosphere. They analyze layers of sediment from the ocean floor, filled with the fossils of microscopic creatures that thrived in specific water temperatures. By feeding all this information into the simulation, researchers can recreate the Earth's past climate with astonishing precision, watching as virtual ice sheets grow and collapse over millennia. The result is a detailed timeline of the Great Melt, showing not just how much the sea level rose, but how quickly it happened in different parts of the world. Some coasts faced a slow, relentless creep, while others might have experienced sudden, rapid jumps as massive glacial lakes broke their icy dams. This digital reconstruction brings the static map of the Paleo Coastline to life, transforming it into a moving picture of environmental upheaval. We can watch a virtual sundel and slowly fragment into islands, or see the Dogger Plains gradually narrow into a peninsula before finally vanishing. But the true power of these simulations lies in their predictive ability. By combining these climate models with detailed topographic maps of the current seafloor, archaeologists can identify the most promising places to search for sunken settlements. The computer can analyze the drowned landscape and pinpoint locations that would have been prime real estate for ancient peoples. It highlights the confluence of two rivers, a perfect spot for fishing and trade. It identifies sheltered lagoons that would have offered safe harbor for early boats. It finds the high ground overlooking a migratory route for game. These are the places where people would have built their homes and where the evidence of their lives likely still remains. This targeted approach is revolutionizing underwater archaeology, turning a search area the size of a continent into a focused list of high-probability sites. With this simulated past as our guide, we are not just looking for random artifacts on the seafloor, we are hunting for the specific neighborhoods of a drowned world. This digital foresight is now our most crucial tool because the very record we seek is facing a new and modern threat. These fragile underwater archives are now facing a modern invasion. The same seabed that has preserved ancient wood and bone for millennia is being churned into mud by the heavy nets of industrial fishing vessels. This practice, known as bottom trawling, drags massive weighted gear across the ocean floor to catch bottom-dwelling fish. It acts like an underwater bulldozer, indiscriminately scraping away the delicate layers of sediment that protect archaeological sites. In moments, a trawl net can shatter a stone tool that survived for 8,000 years, scatter the timbers of a sunken dwelling, and erase the precise context that gives these objects their meaning. The damage is often total and irreversible, turning a potential time capsule into an unreadable jumble. But the threat is not only from fishing. The global push for renewable energy is also placing these sites in peril. The construction of massive offshore wind farms requires driving enormous pylons deep into the seabed. The laying of undersea communication cables and oil and gas pipelines carves long, deep trenches across the continental shelf. While these developments are crucial for our future, they frequently proceed in areas that have never been archaeologically surveyed. The first sign of a lost landscape is often the sound of a pile driver, and by then it is already too late. Even the natural environment itself is turning against these relics. As climate change alters ocean currents and intensifies storm patterns, it accelerates the erosion of sites that have been stable for centuries. Chemical pollution from industry and agriculture makes the seawater more acidic, slowly eating away at delicate materials like shell, bone, and even pottery. The clock is ticking faster than ever before. This has sparked an urgent international effort among marine archaeologists, a desperate race to find and document these sites before they vanish for a second time. Their work is no longer just about discovery, it is a rescue mission, and this mission is complicated by a fundamental question that echoes across the waves. Who actually owns the past when it lies at the bottom of the sea? A sunken city belongs to everyone and to no one. The moment a lost settlement is discovered on the seabed, a complex legal battle often begins, one that can be as difficult to navigate as the deep water itself. The primary framework for these disputes is the United Nations Convention on the Law of the Sea. This extensive treaty grants a nation sovereignty over its territorial waters, typically extending 12 nautical miles from its coast, and control over the resources on its continental shelf. A country like Greece, for instance, has clear legal authority over a site like Pavlopetri found within its maritime borders. But what about a place like Doggerland, which lies in the North Sea between multiple modern nations? The legal waters become instantly murky, and in the vast expanse of the high seas, the international waters that belong to no single state, the question of ownership enters a profound gray area. To address the specific protection of history, UNESCO established the 2001 Convention on the Protection of the Underwater Cultural Heritage. This international agreement sets crucial ethical guidelines prioritizing in situ preservation. This means that, whenever possible, an artifact or an entire site should be left untouched on the seafloor, its context kept intact for future study. The Convention firmly opposes the commercial exploitation of this heritage, standing against treasure hunters who would sell recovered artifacts to the highest bidder. Yet, these ideals are often tested in reality. A commercial salvage company might locate a sunken settlement using advanced sonar, claiming finders keepers. A research institution from one country may want to excavate a site that lies on the continental shelf of another. the original descendants of the people who lived there may assert a spiritual and cultural claim. Who holds the true right? The answer is rarely simple. These tense negotiations over a stone tool or a wooden post highlight a powerful truth. The fierce desire to possess these relics underscores their immense value, not in gold, but in the fundamental story of humanity they represent. Our own bodies carry a map of these lost journeys. While archaeologists piece together the physical evidence from the seafloor, geneticists are reading a different kind of record, one written in the language of our DNA. This biological blueprint holds echoes of ancient migrations, tracing paths that were erased by the rising seas thousands of years ago. The method relies on a powerful comparison. Scientists analyze the genetic code of modern populations, looking for shared markers and unique mutations. They then compare this data to DNA extracted from ancient skeletal remains when such precious samples can be found. By tracking how these genetic signatures are distributed across the globe, researchers can reconstruct the great human journeys, watching as populations split, merge, and move. The drowning of land bridges like Beringia and Sundaland was not just a geological event, it was a profound genetic experiment. As the waters rose, they cut off groups of people from their parent populations. These isolated communities, now trapped on shrinking landmasses or forced onto new shores, experienced what is known as a genetic bottleneck. With a much smaller pool of people to reproduce with, certain genetic markers became dominant, creating a distinct biological signature that was passed down through the generations. This is why the DNA of indigenous peoples in the Americas carries clear, ancient links to populations in Siberia, a connection forged on the now vanished plain of Beringia. Similarly, studies of groups across Southeast Asia reveal a complex genetic tapestry that hints at the ancient unity of Sundaland before the waves fragmented it into islands. This genetic clock can even help pinpoint the timing of these epic migrations. By calculating the rate at which DNA mutations naturally accumulate over time, scientists can estimate when a population first became isolated. A genetic split that occurred around 12,000 years ago, for instance, aligns perfectly with the final submergence of the Bering Land Bridge. This biological evidence does not stand alone. It weaves together with the archaeological finds and the sea level curves to create a single, corroborated story. The stone tools dredged from the North Sea, the drowned villages in the Baltic, and the unique DNA of a person living today in Borneo or Brazil are all threads from the same grand narrative. Genetics adds a deeply personal chapter to this history, confirming that we are all, in a very real sense, the children of those who walked the sunken shores. Machines are now becoming the primary explorers of the deep. Autonomous underwater vehicles, essentially robotic submarines, can glide silently through the darkness for days on end, methodically mapping vast swaths of the seabed without a single human ever getting wet. They are complemented by remotely operated vehicles, tethered bots controlled by pilots on a ship above, equipped with powerful lights and robotic arms capable of delicate excavation. These technologies allow researchers to reach sites that were previously unreachable, plunging into deep underwater canyons or navigating treacherous, current-swept channels where it is too dangerous to send a diver. But the sheer volume of data they collect presents its own challenge. Mapping thousands of square kilometers of seafloor with sonar generates a mountain of information, an endless digital landscape where a single, crucial anomaly could be easily missed by the human eye. This is where a new partner enters the search: artificial intelligence. Scientists are now training AI algorithms to scan these immense sonar datasets, teaching them to recognize the subtle signatures of human activity. The algorithm learns to distinguish a naturally jagged rock from the straight edge of a cut stone block. It can identify the faint, circular pattern of a buried foundation or the long, linear depression of an ancient cart path. This machine-assisted vision is transforming the search from a painstaking, square-by-square examination into a targeted hunt for the ghosts in the data. Yet for all this technological power, our maps still have enormous blank spots. The most promising frontiers remain largely unexplored. Beyond the relative shallows of the continental shelves, the seafloor drops away into the abyssal plain, depths that have barely been surveyed for archaeological potential. And in the tropics, where rich river deltas would have supported large populations, the search is frustrated by thick layers of silt and near-zero visibility. These challenging environments are not empty, they are merely waiting. The next decade of exploration will almost certainly bring revelations that force us to rewrite the early chapters of human history. A single discovery in these uncharted waters, a submerged village off the coast of India, or a ceremonial site in the drowned forests of the Amazon shelf, could fundamentally alter our timeline for when and how civilizations first arose. This is not just about filling in gaps on a map. It is about recovering an entire lost library of human experience. And as we peer into this technological future, searching for the outlines of drowned worlds, we are also holding up a mirror to our own. The same oceans that rose to claim these ancient landscapes are rising once again. The same oceans that rose to claim these ancient landscapes are rising once again. This time, the cause is not a natural planetary cycle, but human activity. The relentless burning of fossil fuels is warming the atmosphere and heating the ocean, causing the water to expand and glaciers to melt at an alarming rate. The slow, geological drama that once unfolded over millennia is now compressed into a single human lifetime. Our modern coastal megacities, from Miami to Mumbai, now stand where the hunter-gatherers of Doggerland once stood, on the front line of a changing world. The story of these sunken civilizations is no longer just a historical mystery, it is a stark and urgent lesson. We are conducting a global experiment with a known outcome, for we have already seen the final chapter. The question is no longer if the seas will rise, but how we will respond. The archaeological record offers us a profound case study in human resilience. When the waters crept into their valleys, did the people of Sundaland simply pack their belongings and move to higher ground? Did the communities around the Black Sea innovate new forms of fishing and boat building to adapt to their shrinking shores? Or did some cultures, too rooted in their traditions and territories, simply refuse to leave until it was too late? These are not abstract academic questions, they are blueprints for survival. Understanding how ancient societies managed the trauma of displacement, the loss of ancestral lands, and the scramble for new resources provides invaluable insight. It teaches us about the social friction that arises when climate refugees move into occupied territories. It shows us the kinds of technologies that become vital for life on a changing coast. Most importantly, it demonstrates the long-term consequences of inaction. The past proves beyond any doubt that coastlines are not permanent. They are dynamic, fluid borders that have always shifted with the climate. Our concrete skyscrapers and seawalls offer a false sense of permanence against a force that has, time and again, redrawn the map of the world. This historical context does not diminish the modern threat, it deepens it, adding the weight of 10,000 years of evidence to our current crisis. The lost continents beneath the waves are a haunting preview, a ghostly outline of what could be lost if we fail to learn from the echoes of our own drowned history. Not every anomaly on the seafloor is a sunken temple. This field of research walks a fine line between groundbreaking discovery and unsubstantiated speculation, drawing sharp criticism from mainstream archaeology. The most prominent debate swirls around the idea of a single, global and technologically advanced Ice Age civilization, a society that supposedly left its mark before the Great Floods. For many academics, this is a bridge too far. The primary objection is a glaring lack of evidence. If such a sophisticated culture existed, where is its widespread trash? Where are the submerged cityscapes with clear, gridded streets, the industrial-scale workshops, or the consistent layers of artifacts that we find at every other major archaeological site on land? The confirmed finds, like the hunting camps of Doggerland or the villages of the Baltic, point to societies that were sophisticated in their own right, but not technologically superior to their terrestrial counterparts. This evidential gap is the single biggest hurdle for the more dramatic claims. Interpretation itself is another minefield. A sonar image can be tantalizing, revealing what looks like a perfect rectangle or a series of concentric circles on the seabed. But the ocean floor is a strange and sculpted place, shaped by currents, landslips, and methane gas eruptions. What appears to be a stepped pyramid could easily be a terraced bedrock outcrop. A line of stones that seems man-made might be the natural fracture pattern of a submerged lava flow. Without physically touching and excavating a site, the data remains open to debate, a Rorschach test where one person sees a city and another sees geology. This ambiguity is why the most respected researchers in maritime archaeology hold themselves to an exacting standard. They do not rush to announce the discovery of a new Atlantis based on a single sonar scan. Instead, they practice methodological rigor, gathering multiple lines of evidence from sediment cores, pollen analysis, and precise mapping before drawing any conclusions. They submit their work to the scrutiny of peer-reviewed journals, allowing other experts to poke holes in their theories and challenge their interpretations. This process, while slow and often frustrating, is what separates science from storytelling. It ensures that every claim is tested and every assumption questioned. Healthy skepticism is not the enemy of discovery, it is its essential partner. It forces the field to clean its own house, to focus on the solid, verifiable facts that can truly redraw our maps of the past. And when a site like Pavlopetri or a landscape like Doggerland is confirmed through this rigorous process, its impact is undeniable. These proven discoveries carry more weight precisely because they have survived the gauntlet of scientific skepticism, offering us not just a captivating mystery, but a tangible piece of our sunken heritage. Off the coast of Japan, a stone giant sleeps beneath the waves. The Yonaguni monument is a colossal, terraced structure that plunges downward for 25 meters, its sheer faces covered in mysterious, sharp-angled formations. To the untrained eye, it looks utterly artificial. You can trace what seem to be massive staircases, wide platforms, and even two towering pillars. Some researchers claim to see a carved turtle and a human face in the stone, suggesting the work of a skilled, ancient hand. The entire site feels like the sunken ruins of a ceremonial center, a place of profound significance lost to the sea. The debate over its origin, however, splits the scientific community right down the middle. Mainstream geologists present a compelling natural explanation. They point out that the rock itself is sandstone, a material known to fracture along straight lines and flat plains. In this tectonically violent region, powerful earthquakes regularly shift the seabed, creating sharp, clean fractures that can easily mimic carved blocks. The relentless ocean currents then act as a master sculptor, grinding and eroding the stone into the terraces and steps we see today. For them, Yonaguni is a stunning example of nature's own architecture, a geological masterpiece mistaken for human art. Yet other investigators remain unconvinced. They argue that the probability of nature creating such perfectly parallel structures and consistent 90-degree angles is incredibly low. They highlight specific features like a narrow trench that seems too straight and uniform to be a random crack, or a platform that appears leveled with clear intent. The fundamental challenge is that we are trying to apply terrestrial rules to an underwater world. On land, a pile of worked stone flakes around a monument would be clear proof of human activity. Underwater, such tiny clues are scattered and lost to the currents in an instant. Yonaguni stands as the ultimate cautionary tale for this entire field. It forces us to confront our own desire to see patterns, to find meaning in the shapes of the deep. It reminds us that the line between a lost city and a fascinating rock formation is often drawn not by what we see, but by the hard, physical evidence we can actually hold in our hand. The search for these lost worlds is no longer just a professional pursuit. Some of the most significant finds begin not in a university lab, but with a fisherman feeling a strange tug on his net or a recreational diver noticing a curious arrangement of stones that nature could not have made. These chance encounters by amateurs have repeatedly proven to be the first spark of a major discovery. A local who knows the hidden contours of a bay might spot a subtle anomaly that a visiting research vessel would miss entirely. This crucial role of the passionate outsider is now being supercharged by technology. Online platforms offer satellite imagery that allows anyone with an internet connection to scan coastlines from above, searching for the telltale dark shapes of potential structures just beneath the water's surface. More formally organized projects are harnessing this collective power through citizen science initiatives. They upload vast, raw datasets of sonar maps to the web, inviting the public to scan the digital seafloor for anything that looks out of place. Thousands of eyes can accomplish in days what might take a small research team years, flagging intriguing features for professional investigation. This collaborative spirit shatters the traditional boundaries of archaeology, transforming it from an exclusive science into a shared human endeavor. It acknowledges that the next great discovery, the one that rewrites a chapter of our history, could come from anywhere. It could be you, studying a satellite image on your laptop, or a diver on a weekend adventure who glances down and sees something extraordinary. The story of our sunken past is waiting, and its pages are being turned by a chorus of many voices. A sunken city is more than a historical puzzle. It is a potential economic engine. The moment a site like the sunken city of Alexandria is confirmed off the coast of Egypt, it transforms from an archaeological dig into an international destination. Almost overnight, it draws scuba divers from across the globe, eager to float above ancient palaces and swim through the ghostly outlines of streets that vanished millennia ago. This influx creates a cascade of local revenue, funding hotels, dive shops, guided tours, and restaurants, all built around the allure of a lost world. This public access does more than generate income. It builds a global constituency for preservation, turning abstract history into a personal, unforgettable experience. Yet this very attention introduces a grave new threat. Without meticulous management, the gentle fin kick of a single diver can stir up sediments that have protected artifacts for centuries, while uncontrolled crowds can accidentally break fragile structures or dislodge crucial context. The far greater danger comes from looters who see not a cultural treasure but a marketplace, illegally salvaging artifacts to be sold on the black market, erasing their stories forever. This creates a complex balancing act. How do we allow people to witness these wonders without loving them to death? The answer lies in a model of responsible tourism. This can mean installing fixed guidelines to control diver routes, creating detailed 3D virtual tours for those who cannot visit in person, and strictly limiting the number of visitors each day. These sites are fundamentally non-renewable. A stone tool removed from its resting place loses all its scientific meaning, and a collapsed wall can never be perfectly rebuilt. Their immense economic value is inextricably linked to their authenticity, a value that plummets the moment they are damaged or stripped bare. When managed with care, however, the revenue from tourism can directly fund further research, advanced conservation labs, and site protection, creating a virtuous cycle where public fascination fuels the very science that makes the discovery possible. This financial incentive adds a powerful, modern-day argument for why these drowned landscapes matter, transforming them from academic curiosities into vital, living assets for both the present and the future. No single scientist holds the key to these drowned worlds. Unraveling the mystery of a sunken civilization is a quintessentially human endeavor, a collaboration that spans the entire scientific spectrum. A geologist reads the layers of sediment on the seafloor, dating each stratum to understand when the land was dry and when the sea finally claimed it. A climatologist feeds that data into complex models, recreating the ancient weather patterns that governed the lives of the people who lived there. When a skeleton is recovered from the mud, a geneticist extracts its DNA, tracing lineages and migrations that written records could never capture. Each specialist brings a different lens to the same fragment of evidence, and together they create a picture far richer and more reliable than any one perspective could achieve alone. The story of the Ice Age shorelines is a colossal jigsaw puzzle scattered across the ocean floor, and each scientific field holds a vital piece. An archaeologist might find a stone spear point, but it is the oceanographer who explains the currents that deposited it there, and the botanist who identifies the pollen grains stuck to its surface, revealing the very environment the hunter once stalked. This synthesis is the future of historical discovery. It moves us beyond mere artifact collection and into the realm of true world building, allowing us to not just find a lost village, but to understand the climate its people lived under, the food they ate, and the journeys their descendants took after the waters drove them away. The ultimate map of our past is not drawn by a single hand, but is a collective masterpiece, a testament to what we can uncover when we bridge the divides between our sciences.